Let's start by adding the entities to our application. These entities, just like the DTOs we've used before, are simple classes. But as we learned, the DTOs, the outer-facing model, are different from the entities, the entity model. Not all fields, like computed fields, are stored in a database, and the data we want to offer through an API is often shaped differently than how it is stored in the underlying data store. So it's very important to make this distinction. I like to add these to their own namespace, so let's add a new folder. We'll name the folder Entities. We've got two entities we want to add, one for the city and one for the point of interest. Let's start with city. We right-click our folder and choose to add a new class, and we name it city. A city entity has an ID, a name and a description, and it also has a list of children, a list of point of interest. Just as before, it's a good idea to initialize this to an empty list to avoid null reference exception problems when you're trying to manipulate a list when the points of interest haven't been loaded yet. Next to that, name is a field that we don't want to have a null value. We could initialize it as an empty string, just as we did with our DTO. But for entity classes, I prefer to be a bit more explicit about how we want this class to be used. A good way to do that is by adding a constructor that accepts a name parameter. As you know, adding a constructor to a class ensures that the default parameterless constructor is no longer generated. That doesn't mean that someone who is using this class cannot override this and input an empty name nevertheless. We are working with .NET, which supports reflection, and there's really not much you can't do with a bit of reflection. Nevertheless, like this, we convey purpose to our fellow developers or other people that might inspect or use our code. We convey that we want this city class to always have a name. In our city DTO class, we also had a calculated field, number of points of interest. We omit that in our entity because we don't want to persist that to our database. By giving the class an ID with name ID, this field is automatically regarded as the primary key. City ID, in other words the class name followed by ID, would be possible as well. If we would name this differently, the convention does not apply, but we can apply the key data annotation from system.componentModel.dataAnnotations. We need to import that namespace, so let's add a using statement by pressing Enter. Personally, I like to apply the key annotation anyway, even if convention would ensure that this property would be regarded as primary key. I feel it makes entity classes somewhat more understandable at first glance. But well, I've got that same gripe with a lot of convention-based approaches, so this is totally up to you. Another thing of importance is the generation of these ID primary keys. By convention, primary keys that are of an integer or GUID data type will be set up to have values generated when we add them. In other words, our ID will be an identity column. To explicitly state this, we can use the database generated annotation from system.componentModel.dataAnnotations.schema. It has three possible values: none for no generation, identity for generation on add, and computed for generation on add or update. We need identity as value. That means that a new key will be generated when a city is added. How the value is generated depends on the database provider being used. Database providers may automatically set up value generation for some property types, while others will require you to manually set up how the value is generated. In our case, we're going to be using SQLite, so we're good to go. A new integer primary key will be auto-generated without further setup. So far for the city entity. Up next is the point of interest entity. Let's add a new class to the entities folder, and we name it point of interest. A point of interest has an ID and a name. Let's refrain from adding the description for now, as that allows us to tackle migrations later on in this module. We apply the key and database generated attributes here as well. But there's more. we want to signify the relation between city and point of interest. On city, we already defined a collection of point of interest. But we want to be able to navigate through our object graph from a point of interest to the parent city as well. So we need a property to refer to that parent city. And we need to state what the foreign key property will be. Again, there's a convention-based and an explicit approach possible. By convention, a relationship will be created when there is a navigation property discovered on a type. A property is considered a navigation property if the type it points to cannot be mapped as a scalar type by the current database provider. So if we add a property city of type city, this is considered a navigation property and a relationship will be created. Relationships that are discovered by convention will always target the primary key of the principal entity. In this case, that's the ID of the city. That will be our foreign key. It is not required to explicitly define this foreign key property on the dependent class. And the dependent class in this case is our point of interest class. But it is recommended, if only for clarity. So I prefer to add one. If we do not want the convention-based approach to be followed, which states that the foreign key will be named according to the navigation properties class name, followed by ID, which in our case translates to city ID. Well, if we do not want that, we can again use an annotation for that, the foreign key annotation. Here we state that for navigation property city, the foreign key on point of interest is named city ID. Again, this isn't strictly necessary as the convention-based approach is sufficient in our case, but I do believe it makes what we're doing more clear to fellow developers. So, the differences between entity classes and our DTOs are becoming more clear. DTOs typically don't contain these properties and annotations. But there's more. We've applied annotations to our DTOs that we used for create and update, like required for name and maximum length. If we leave our entity classes like this, our database columns will allow empty strings for fields that shouldn't have an empty string as value, and will be of max and varchar length instead of a specified maximum size. It's best practice to ensure that these field restrictions are applied at the lowest possible level, and in our case that's the database. This ensures the best possible data integrity. So let's apply these attributes. Name was required with a maximum length of 50, and for the city entity we want these as well. Name is required with a maximum length of 50, and let's give the description a maximum length of 200. We didn't have these attributes on our city DTO, and we don't need them because, as you remember, the city DTO is only used to get data, not to store it. Okay, so we've got our entities, and we can see that these are definitely different from the DTOs we've been working at. Both on a level of missing properties, like the calculated number of points of interest for a city, and as far as additional properties are concerned. Like the navigation property from point of interest to its parent, city. Now we need some sort of class from which we can access these to get data from the database and persist to the database. That's what we'll tackle in the next demo.